All right, everybody, welcome back to our research methods, and we are doing section 6 today, which is all about validity, right? So we've talked about reliability prior to this. We've touched on a little bit of the validity stuff, but here we're going to go into a little bit of a deeper dive, okay? Now, as I said in an earlier section, there are 4 kinds of validity. Statistical validity, we're not really going to talk about in this class. We'll leave that for a statistics course, but it's essentially, are your statistics doing the right thing? Are you using the proper techniques, right? Construct validity we talked about in a previous section, which is all about how well your measures are really grasping and measuring and quantifying the entirety of the concept you have identified that you're trying to develop those measures to measure, right? So we're going to talk a little bit more about external and internal validity today. External validity is relatively simple, okay? External validity is just how well our results translate to other people, other places, or other times. In other words, how generalizable are our findings, right? If we do an experiment only on white men, does that necessarily translate to other men of men of other races or women, right? And this was one of the big problems with early 20th century and even mid and late 20th century medical research, was that all of the research was done on white men. There was very few medical studies done on women, on people of color, right? And there are medical differences that need to be where you need to take race and gender into account. So the external validity of those studies was not necessarily good for other genders and other races, right? If we do a study on Americans, say about crime or socialization or things that sociology and criminal justice might tend to do studies on, do any conclusions we make apply to Canada or Japan or South Africa, right? Those are very different groups of people. And since we're studying something sociologically, does the different society, will they have very different results if we did the same study on them, right? So doing any given study, it's difficult in many cases to say whether your conclusions apply to humanity in general or all of the people of the country rather than just the specific subset you took a sample from. But how well do your results, do your conclusions really translate to other groups? And how much is it going to translate 50 or 100 years from now, right? That kind of thing. Now, internal validity is a lot more complicated. And just like how we talked about with construct validity, where construct validity is this umbrella with multiple different kind of subcategories within it, internal validity is the same way. So with internal validity, there are lots of different subcategories, subsections, sub-threats to the internal validity of a study if you don't take care and control for them, right? So we're going to talk about some of them here. One of them, the first we're going to talk about, is selection. And selection bias is the threat to internal validity that happens when you have two groups, but the groups aren't the same to begin with. And hopefully random assignment kind of controls for this and takes the selection bias out of the equation, which is one of the reasons random assignment is so important, right? But with selection bias, we have in a prison, some prisoners get a rehabilitation program. Then we measure the recidivism after they leave prison, and the prisoners who got the rehabilitation program have much lower rates of recidivism than the group that didn't get the rehabilitation program. But unless we randomly assign prisoners to either get that rehabilitation program or not, how do we know whether the decrease or the lower recidivism rate was due to the rehabilitation program and not the fact that the prisoners who got sent to the rehabilitation program were the prisoners less likely to recidivate anyway? Right? That's a selection bias issue. In other words, the two groups weren't the same at the beginning of the experiment. Thus, of course, they're going to be different at the end of the experiment. Right? You can also help at least identify this by using a pretest kind of design. So even if you can't have random assignment, if you can have a pretest, you might be able to at least determine whether there is a selection bias issue that is there. The second one on the list is attrition, right? Also called experimental mortality. And this is where people drop out of your experiment unevenly, right? So let's go to a boot camp program for juvenile offenders, right? We randomly assign juvenile offenders to either the traditional juvenile detention or this boot camp program. Now we've got this random assignment, so hopefully we can say that selection is not a problem. The two groups are equivalent when they begin, right? We're going to assume that there is no selection bias here. But when juveniles in the boot camp program kind of do something wrong, they do bad, they're really uncooperative, they get kicked out of the boot camp program. Whereas juveniles in juvenile detention, if they do the wrong thing and are causing problems and not following the rules, they're not getting kicked out of juvenile detention. They're just staying there, right? So if we see a difference at the end, if the juveniles from the boot camp program have lower rates of recidivism, it might not be because of the boot camp program itself. It might be because all the worst of the juvenile offenders, the ones who were going to recidivate anyway, dropped out of the program. And thus their recidivism numbers aren't measured in that observation at the end. Thus it's kind of artificially lowers the recidivism rates of that group, making the boot camp program look more impactful than it really was. So attrition is when members drop out of your study non-randomly. Okay? If it's a people are going to drop out of your study in every study. But if they drop out essentially randomly, then we can assume, hopefully, that it hasn't changed the groups in any really meaningful way. Third one on here is testing, right? And testing, again, I alluded to in the previous section. This is where the mere act of taking the test influences the second test or the second observation. So the mere fact of being observed the first time changes the measurement of the observation the second time, right? So if I just sat you down and asked you to name all 32 NFL teams, let's see how many you can name, right? And then a month later, I sit you down and I ask the exact same question. You're probably going to get more teams the second time than you did the first. Not necessarily because of any intervention I gave you between the first and the second, just because you do better at it the second time around. You know a little bit more of what to expect. You're prepared for it. You understand what's going to happen. It's not a new thing. You're going to do better the second time anyway, right? Fourth one there is maturation, i.e. people grow and change over time. So if I just grab a sample of juveniles for a study on crime, I pull a sample right now today of 1,000 15-year-olds, and I give them a survey about how much crime they've committed. And then I use the exact same sample and I give them a survey about how much crime they committed in the last year, every year for the following 20, 30, 40, 50 years. I'm going to find that their crime rates kind of peaked in their early, late teens ish, and then go down. Not because of any intervention I might be giving them, not because of anything that might be happening, other than the fact that they're getting older. People's crime tendencies follow a very predictable pattern. And it's not, so if I measure somebody's criminality at 20 and then again at 30, that second observation is going to show much less criminality, not necessarily due to anything I did in the meantime, but just because they've gotten older. And their criminality naturally goes down because they're getting older, right? So that's a maturation problem. All right, regression or regression towards the mean, okay? This is another one kind of similar to the testing effect, where it involves multiple observations, multiple measurements, right? And what regression towards the mean signifies is that when you have your first observation, when there are outliers, really high scores or really low scores, the second time you observe them, those outliers are almost definitely going to be more towards the middle on the second observation, right? So if you look at your favorite sports team, or let's just go your favorite sport, right? Maybe it's baseball, maybe it's football, maybe it's basketball, whatever. Think about the previous year in that sport. And think about what team had the best record and what team had the worst record. I will bet you any amount of money you want that next year, the team that had the worst record in your sport will have a better record than they did last year. And the team that had the best record in your sport is going to have a worse record than they did last year, right? So I'm a football fan. So last year, let's say a team went 2-15, 2 wins, 15 losses. Next year, I will almost guarantee you they will get more than 2 wins, knowing absolutely nothing else about them, because it's nigh on impossible to get worse, and it's a lot easier to get better, right? But if last year there was also a team that went 15-2, 15 wins and 2 losses, I'll almost guarantee you they're going to get worse, because it's nigh on impossible for them to get better, right? So that's just regression towards the mean. That's where outliers in one observation get a little bit more towards the middle on any subsequent observations, right? Next one there is a history effect. Now, a history effect just means, we do an observation, some amount of time passes, and we do a second observation. And we hope that any change we see between the first and the second is due to whatever intervention we're trying to measure. But what if something completely different happens? Something out in everyday life, there's a big news story about something, and that changes how whatever our dependent variable is, right? So maybe we're looking at politics, and we want to know whether this, we're going to take a group of people, ask them who they're going to vote for, then we're going to give them this education program where they learn all about political science and all this, this stuff that is very important, democracy, and here's why voting, and here's the 2 parties, and why their candidate is good and why their candidate is bad and all that stuff. And then we're going to ask them again after a month, who are you going to vote for? And we're going to see how this program has changed their voting preference, right? But we do our observation, we ask them who they're going to vote for, then during that month where they're being educated, some major news story breaks, right? One of the 2 candidates murders somebody on live TV, or one of the 2 candidates, it comes out that they're, some kind of scandal. Then when we do the second observation, and we see this difference in how people are voting, how do we know whether the difference between the first observation and the second observation a month later was due to this intervention, this educational program? What if it's due to just the fact that there was this big scandal, or this, this thing happened completely outside of our control, completely outside of our experiment? That's a history effect. I did a study a few years ago where we were asking people about gun laws. And we wanted to do a survey, but I couldn't send the survey to all of the people in one day. My email client wouldn't let me. So I had to split it up over 3 days. I sent an email asking people to participate to a third of the sample on day 1, another third of the sample on day 2, and another third of the sample on day 3. And I was really, really, really hoping that there wasn't some major gun crime that happened, say, on day 2, because then it would be kind of impossible to really compare the surveys from day 1 and day 3, because they would not be equivalent. The people who got the survey on day 3 would be very different because of this history effect than a person who got it on day 1, right? The third thing there is instrumentation. And this is the device or technique that we are using to take our observation may change over time. So let's say we're doing a study on weight loss. So we use a scale, a physical, real scale that people stand on to get their weight taken, right? And when the study starts, it's a very accurate scale. But then over time, we weigh a whole bunch of people, and that scale, just through use, gets less and less and less accurate. That might cause us to see a change at the end that's not due to any actual change in the real world. It's due to the fact that our scale has gotten less and less and less accurate over time, right? Now imagine it's a person, and I'm hired to do interviews for a researcher doing a research study. And my first few interviews, I don't really know what I'm doing. I kind of, I'm not experienced in giving interviews. So I get one set of data, but by the end of the process, I continue to give more and more and more interviews. By the end of it, I'm a much better interviewer, and I'm able to obtain different data than I did in those first few. So my change as an interviewer is going to result in different data from beginning to end, not based on changes in the people I'm interviewing, but just me as the interviewer has changed. And then the last one here is ambiguous temporal precedence. This is where it's impossible to say what happened first and what happened second. We want to, it's not clear what happened exactly when. It's kind of ambiguous, right? We can't dictate, oh, well, clearly this came first and that came second and that came third and that came... It's all kind of muddled up, and we can't tease out the time order part of our experiment. All right, so some other kind of sort of threats to internal validity. There are definitely issues with research that I'm going to talk about here in this section. One of them is contamination. This is where we give our treatment to the treatment group, but it somehow leaks out and infects or affects the control group as well, right? And I actually had a literal form of this happen to a friend of mine. A friend of mine worked for an NGO somewhere in some third world country. And this charity was going in, and they wanted to know whether giving these pills to a group of people, how good it would do reducing some parasitic infection, right? And so they're in this very rural area of this third world country, and they decide there's 2 villages. Okay, we're going to give this pill to one village and not the other, and then we're going to see how well their parasite infections change, right? And what we hope to see is that the group who's getting the pill, their parasitic infections go way, way, way down. And the control group, theirs essentially stays the same. Thus, we've proven that these pills really help in this particular situation, in this very rural area of this third world country. And then we can start giving these pills to everybody, and we can save a lot of lives and make people's lives better. But what they found, they gave the pills to the one village and not the other. And what they found was the parasitic infections dropped in both groups. And they were really, why? There's no reason why these infections should have dropped in this second village that didn't get these pills, until they figured out that both villages were on the same small river. And the village that got the pills was upstream of the village downriver. And thus, the village upriver were taking all these pills, getting the effects of the medication, and then they were essentially going to the bathroom, urinating, and through the water table, the drug was at high enough levels in their urine that it got into the river, and then the village downstream was drinking that water and got enough of the drug to actually reduce their parasitic infections too. So that is a quite literal kind of contamination there. But it might also be something like, we go into a prison, we have an experimental group and a control group of prisoners. We give the experimental group anger management classes, right? But unbeknownst to us, after those anger management classes are over, they're going back out into the prison population, and they're kind of teaching these new techniques to all the other prisoners. And so even the prisoners that were in the control group are learning these anger management techniques, not from the teachers we've hired to give the lessons, but from the other prisoners in the experimental group. So that's all contamination. The second and third here on this slide are kind of related. They're compensatory rivalry and demoralization. And this happens when people kind of know they're in the control group. Right? So in our previous example, we've got this prison. Some of the prisoners get rehabilitation courses or anger management classes or whatever. And let's say there's no contamination. The prisoners who have gotten this training or education or whatever, they're not teaching it to the control group prisoners. But there's kind of two reactions that control group can have if they know what the experiment is about. They know they're in the control group. They know essentially ballpark what is happening to the experimental group and what the researchers are hoping to study here. Compensatory rivalry would be, well, I didn't get that rehabilitation program. I didn't get that anger management class, but I'm going to do better anyway. I'm going to work on my anger. I'm going to count to 10 and breathe and things I learned prior to coming to prison, so I can reduce my anger levels because I'm upset and I want to be just as good as those prisoners who did get this new rehabilitation program. And so they're going to kind of artificially inflate whatever we're measuring to make themselves look better because they want to, they have this rivalry, if you will, with the group that did get that experimental, the group that is the experimental group. And thus they kind of make themselves look better in comparison, right? But they could also be like, those stupid experimental group, they're getting all these benefits, all these things. That really upsets me that I'm not in that group. So I'm going to make it worse. I'm going to get even angrier. I'm going to not work on job skills and education and, specifically ignore that stuff because, I'm really upset with those stupid experimental group guys and how dare they not pick me for their stupid study and blah, blah, blah. So in both cases, kind of knowing that they're in the control group will cause them to kind of go in one of two directions as a kind of compensation for that process and because they know they're in the control group of that study. All right, another thing we have to worry about are the expectancies of the experimental staff. right? So if I'm the one in charge of doing the observing, whether it's running medical tests or doing interviews or coding data from a questionnaire or whatever, if I know what's going on and I know who's in the experimental group and who's in the control group and all those things, I am going to make, usually not conscious, usually subconscious, changes in what I do and how I do it and how I act based on what I expect, right? So if I'm doing a medical trial and I know you're in the experimental group and I know this person's in the control group, when I do your medical tests, I might subconsciously kind of, if I know you're in the experimental group, I might, round down your blood pressure numbers. Whereas if you're in the control group, I might kind of subconsciously expect you to be worse, so I'm going to subconsciously round up your blood pressure numbers, And so just the fact that the experimental staff, the people doing the measuring and the observing, kind of know what's going on and know what's supposed to happen can cause them to record something as if it is happening when it might not be, right? And this is why in medical trials they always do what's called a double-blind study. And that's where neither the patients nor the doctors actually treating them know who's in the experimental group and who's in the control group. So that way the doctors are going to evaluate people and treat people the exact same, no matter which group they're in, because even they don't know. They have no idea whether any given patient is getting the real drug or the placebo, right? Which brings us to the placebo effect, which I talked a little bit about in an earlier section. But this is one of my favorite kind of fun discoveries of science. And that is that if you give somebody any kind of treatment, even if it's completely nonsensical, it will have an effect on them and their views and behaviors and all those things, because the human mind is incredibly powerful. And with a literal placebo, it's used in medical studies where, if the experimental treatment is a pill, they'll give the control group a pill that looks the exact same color, same size, same shape, but has no active ingredient in it. It's just essentially a sugar pill, right? Because they know that just the mere act of taking a pill will change people's medical stats, right? It's not going to cure your cancer, but it can make people feel better. It can make people, just their brain thinking, I'm getting a treatment, improves mood, can reduce blood pressure, can do all kinds of little things that make it actually have an effect. It's a complete nonsense, nothing pill that has no active ingredients at all, but it will still have an effect because people expect it to have an effect, right? So if we go into prisons and we have an experimental group that's getting job training, we could theoretically give a placebo to another group and say, oh, we're going to teach you all about Batman and how cool Batman is. And while the experimental group is getting lessons on, job training or whatever, we're going to give you lessons on how awesome Batman is. And theoretically, that shouldn't affect recidivism or their ability to find a job after release from prison or whatever it is we're trying to study. But it might, because this placebo effect is so strong and so powerful. And then finally, the last thing we're going to talk about is the Hawthorne effect. And this one is also really fascinating. The Hawthorne effect refers to an effect first noticed by a researcher named Hawthorne, where they went into some factory, and the factory was making widgets of some kind. And I might be screwing up some details here, but the basic story is they had workers on an assembly line making widgets, right? And they measured how many widgets that the people were making per hour or whatever before the experiment started, right? And then they started the experiment. And with the experiment, what they did was they tried a bunch of different techniques to increase the production rate of the widgets. They tried music. They tried reading to people. They tried turning the lights brighter, making the lights darker. They tried doing this. They tried doing that. They tried all these different things. And what they found was literally everything they did increased the production rate for widgets over and above what it had been before the experiment. Literally everything. And they're like, how could it? Like, they're contradictory things, like turning the lights brighter and turning the lights darker both increased production rate. How could that be? And what they finally figured out was it wasn't the changes they were making. It wasn't the lighting. It wasn't the music. It wasn't the different uniforms, whatever. It was the mere fact that the people making the widgets knew they were being observed. There was a scientist there with a clipboard. They knew they were the subject of an experiment. And as such, just knowing they were the subject of an experiment and they were being watched and their actions and their production rate was being counted changed their behavior. So just the mere fact that they knew they were under observation changed how many widgets they made per hour. So now the Hawthorne effect refers to the fact that people are going to behave differently when they're not being watched, not being measured, not being observed, versus when they are being watched and observed and measured. Just because they know they're being watched. Just because they know that their production rate of widgets or their criminality or their whatever is being observed by somebody else. Okay? All right, that's all I have for this section. Thank you so much. I'll see you in the next one.